Welcome to Jom Studylah YouTube channel. Today, we are diving into an important A-level chemistry topic, hydrocarbon. These are the building block of organic chemistry and play a key role in plastic, fuel, and many everyday materials. So, without further ado, let's get started. Alkene. Alkene is a type of hydrocarbon. Hydrocarbons are made of only carbon and hydrogen atoms. They are divided into two main types, which is aromatic hydrocarbon, which is organic compound, contain one or more benzene rings, have a special ring structure. Secondly, is aliphatic hydrocarbon. Aliphatic hydrocarbon is an organic compound, do not contain benzene ring, and it splits into three main groups: alkanes, alkenes, and alkynes. Alkene is a saturated hydrocarbon, which is organic compound, contain only single bond between carbon atom, and it can be straight change alkane, cycloalkane, carbon atom form a ring. Alkene is unsaturated hydrocarbon, which is organic compound, contain at least one double bond. It can be straight change alkene, cycloalkene to form a ring with a double bond. Alkenes is unsaturated hydrocarbon with organic compound contain at least one triple bond. So this is the diagram which interpret the types of hydrocarbon. From these three levels is explain the one that I already explained just now. Saturated hydrocarbon and unsaturated hydrocarbon. Saturated hydrocarbon, example alkenes, alkanes, and cycloalkanes, which is organic compound contain only single bond between carbon atom, and saturated hydrocarbon has as many hydrogen atom as possible attached to its carbon atom. Meanwhile, unsaturated hydrocarbon, for example, is alkene, cycloalkenes, alkynes, and aromatic hydrocarbon. They are unsaturated hydrocarbon which have fewer hydrogen atoms than the maximum number that could hold. Each carbon atom is sp3 hybridized and it has a tetrahedra shape with 4 single sigma bond made by its 4 sp3 hybrid orbital, and the bond angles are around 109.5 degrees. The IUPAC, which is International Union of Pure and Applied Chemistry, names of alkene and with dash A and E. Alkenes. Alkenes are known as saturated hydrocarbon. Organic compound contain only single bond between carbon atom. General formula for straight change of alkanes is CnH2n plus 2, where n is greater than 1. The first 10 unbranched alkanes, example given here is methane, having the formula, molecular formula CH4, and the structure formula is CH4. And number of carbon atom is 1. Next, we look into the ethane. Ethane number of carbon atom is 2, and the molecular formula is C2H8, and the structure formula is CH3-CH3. Corrections, the molecular formula is C2H6. Next, we have propane. Propane number of carbon atom is 3. The molecular formula is C3H8, and the structure formula is CH3-CH2-CH3. Next, we have butane, where number of carbon atom is 4, and the molecular formula is C4H10, and the structural formula is CH3-CH2 in the bracket 2 joined to CH3. Next, we have pentane, which is number of carbon atom is 5, and the molecular formula is C5H12, and we have the structure formula is CH3 connected to CH3 in bracket CH2 in bracket 3 and connected to CH3. Next, we have hexane, with the number of carbon atom is 6. Molecular formula is C6H14, and the structure formula is CH3 connected to CH2 in bracket 4, connected to CH3. And then we have heptane, where number of carbon atom is 7. The molecular formula is C7NH16, and the structure formula is CH3 connected to CH2 in bracket 5 and connected to CH3. Next, we have octane. The number of carbon atom is 8. Molecular formula is C8H18. Structural formula is CH3 connected to CH2 in bracket 6, connected to CH3. And then we have nonane, which is number of carbon atom is 9, and molecular formula is C9H20, and the structural formula is CH3 connected to CH2 in bracket 7 and connected to CH3. And finally, we have decane. Number of carbon atom is 10. The molecular formula is C10H22, and the structural formula is CH3 connected to CH2 in bracket 8 and connected to CH3. Next, we have the alkane. This is how does the molecular structure is being connected. Methane, ethane, propane, butane, and pentane. And the next we have butane, where this is the diagram for butane, the molecular structure, where the green color is the carbon atom and being connected to the hydrogen. And on the left-hand side is a diagram which indicate in the middle part, the blue color is represent the carbon atom and being connected to the hydrogen. Then we have isobutane, and this is the diagram where we have 2-methyl propane. Starting from butane C4H10, alkane can show change isomerism, meaning that they can have different structure either in a straight change or with branches. And then we have pentane. This is the C5H12, where we have this molecular structure for pentane, which is 2-methylbutane, and this is isopentane. And then we have neopentane. So IUPAC is an international union of pure and applied chemistry, is an international organization in the field of chemistry. This is the way this organization decide the name of hydrogen-carbon molecular structure. Branch change alkane by following more than 3 steps. So for IUAPC nomenclatures for several steps, we have for step 1 until step 3 in this presentation slide. Example C7H16, which is parent's name is heptane. First step, what you need to focus is you have to find the longest continuous change of the carbon atom, and this change gives the main names of the alkane. So how to find the longest continuous change is through this path. Then the next step for the example given here is hexane is C6H14. Second step is look into the number, the longest change starting from the end that is closer to a side group to call substituent. So in this case, CH3 is a substituent. So first, you need to name the number. Through find the number, the longest change starting from the end, where that's why there is one start from the end that is closest to a side group, which is substituent. So you name it 1, 2, 3, 4, 5, 6, and that's the second step. And this is the example for the heptane, where you need to find the number, the longest change starting from the end that is closest to the side group of the substituent. And then the third steps, the example given here is the heptane, where you have to refer the step number to determine the position of the substituent. So from here, so the substituents is come from the end, from this side. So it comes, this is the substituent, so you have to count from the bottom. So 1, 2, 3, 4, 5, 6, 7. That's how the IUPAC nomenclature decide the names of the formula or the molecule formula for the particular hydrocarbon. And finally, you have some common substituent group. For methane, you have names is methyl, the substituent is CH3, ethane is ethyl, CH2, CH3, propane is propyl, CH2, CH2, CH3, isopropyl is CH, CH3, CH3, and butane is butyl, CH2, 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 CH3. And now you look into the isomer of the butyl, C4H9 group, and this is how it looks like. For the butyl group is isobutyl, the structure with this drawing, and SEC butyl, and this is the structure, and terbutyl is a straight line. The change is a straight line to the below. And neopentyl is more a slick line to CH3 below. And then let's look into the hydrocarbon used in organic chemistry for the cyclic and aromatic unit, where you have cyclopropyl, and this is the symbol, like a triangle, and the structure, molecule structure, more or less is like a triangle. How does the carbon and hydrogen is being organized? And for the non-aromatic, we have cyclobutyl. The symbol is triangle. It's not triangle, it's square. And where the arrangement of structure molecule also in a form of square. And then we have aromatic pentyl, phenyl, where you have a circle in the symbol, and the way it organized the molecule structure is also similar to the symbol. And it same goes to the aromatic for benzyl, where the symbol is, there is a circle in the middle, and the way it's arranged, the molecule structures also in the forms of this pattern. And finally, we have some common substituent group. For bromo is the subsequent display as Br. For chloro is Cl, fluoro is F, represent fluoro, and I is represent iodo, and NH2 represent amino. Without being said, that concludes today's sessions, and I look forward to see you at the next sessions. And please subscribe to Jom Study Lab YouTube channel. Don't forget to turn on your notifications so that you don't miss any update. And best of luck in your study and upcoming examination. Thank you very much for your support.